Okay, we're taking a look at problem 107D from chapter 3. So the first thing we need to do is we need to factor all four of these. We're also dealing with a division problem, so we can take that division problem and make it into a multiplication problem. But step one is to go through and factor everything. So taking a look at the numerator here, 4x minus 12. There's just two terms to this one, but one way we can think about it, we can still make a generic rectangle if we want to. We don't necessarily need to, though. But if I made a generic rectangle, there is no x squared term, so that's 0. I also have there's my x squared term. I also don't have another term here. All I have are these two right here, 4x and a negative 12. Now when I look at what is common there, I can get a 4 out of both of those, and then what goes on top there would be an x and a negative 3. So that is factored into 4 times x minus 3. Taking a look now at my denominator. Notice on this one that my leading coefficient is 1. That is a 1 right there. That's my a value. So with that, I can still make a generic rectangle and plug in my first term and my last term. Then I make my diamond problem, multiply those two together and go in the top, and my middle term goes in the bottom. And figure out what multiplies together to be negative 10x squared, adds together to be 3x, and that's going to give me these two numbers, which then get put into my generic rectangle. Now, again, because my leading coefficient is a 1, my a value here is 1, the values that are going to go right here and here will always be x and x. Those will always be 1x and 1x. There are no other options. So I have an x there, I have an x here. Now, what that does is makes this number right here always the exact same as that one. And this number here is always the exact same as that one, which are the values we had from right here, which also are the multiples of negative 10 that add to a positive 3. So whenever we have a leading coefficient of 1, and it only happens with this, we don't necessarily need to make a generic rectangle and diamond problem, because the numbers we would get here and here end up being our answers for our factors. So our factors here are x plus 5 and 2x, or an x minus 2 rather. Now looking at the other fraction, I had this binomial, or trinomial rather. Generic rectangle for this one, I have to make a generic rectangle here because my leading coefficient here is not a 1, it's a 2. So go through and I fill in now my diamond problem. I may notice here that multiplied together they are positive, but added together they are negative, which means both numbers have to be negative in order to multiply together to give me a positive. So it's a negative 7x and a positive 6x. Those get moved then into my generic rectangle, and I take out the factors that are the same. So from negative 7x and 2x squared, I can take out an x, which means then I have a 2x right there. That makes that one a negative 7, and then a negative 3. So I have my factors for that one. And the last trinomial here to factor. Again, make a generic rectangle, fill in the information there, and my diamond problem. This one's going to be a 10x and a negative 7x, which gets then moved into my generic rectangle. I take out a common 2x from the 10x and the 2x squared, which makes then the left side there just an x. 2x times 5 will be 10x, and x times negative 7 will be negative 7x. So my factors are written here. Now, back to this problem now that I have all the factors figured out. Again, I need to take this division problem, switch to a multiplication problem, and when I do that, I use the reciprocal. That is going to then give me this fraction. Since I am now multiplying, I can think of this as being one fraction bar. Everything in the numerator is multiplied together because I'm doing multiplication. Everything in the denominator is multiplied together, again, because I'm doing multiplication. So I can now make my giant ones. My x plus 5 and x plus 5 make a 1. My x minus 3 and x minus 3 make a 1. And my 2x minus 7 and 2x minus 7 make a 1. That leaves me with just 4 over x minus 2 left. And that is simplified.